All right, so we will be talking about what developers want from IDPs. IDPs obviously stand for a lot of different things. We've heard identity providers. In this context, we're talking about internal developer portals. And so one of the big things we always think about is as you're rolling out an internal developer portal, how do you drive adoption? How do you drive engagement? How do you actually get people using the portal that you've built? And so a little bit about me and the company that I'm here with. My name is Ganesh. I'm one of the co-founders and CTO at Cortex. Cortex is an internal developer portal. It's designed to help developers take ownership over their software, their services, their components, the quality of those things, the reliability, in a very efficient way without manual overhead. And the whole goal of Cortex is to create a culture of continuous improvement, reliability, enabling productivity. And you'll hear me talk about continuous improvement a lot. It's a theme that'll keep coming up because when you think about developer portals, what we really want to do is help development teams get a little bit better than they were yesterday and the day before and the day before. And you keep doing that, and you have a great organization at the end of it all. So today's agenda, we're going to be talking a little about the tech landscape, what's happened over the last 5 years, the last decade, how do internal developer portals help with some of this stuff, and how do we help developers improve their own work as a result of all this change. So last 5 years, modernization, why now? Why are we talking about developer portals now? We have had an introduction of microservices, right? The last 10 years, microservices have become a big thing, and there's been ups and downs in that journey, but generally people have headed in that direction of let's build small, reusable things, let's have them all work together, and it's enabled development teams to work in parallel, efficiently, ship independently, in theory, assuming you're not building a distributed monolith, but you can move faster as an organization. Kubernetes has kind of accelerated this, where people can build very powerful internal platforms, deploy faster, operate things at scale, learn from each other. Obviously, cloud computing has been a big trend. It's made hosting cheaper, storage cheaper, again, for the most part, and it's enabled teams to move faster, deploy quicker, and get things to production faster. And last but not least, developers just have more tooling available to them, right? Every time we see a problem, a company, a product, something spins up to help developers with those issues, whether it's CI/CD, whether it's developer portals, better monitoring, alerting, productivity tools, all these kinds of things have come up to help engineering organizations ship better. And so at the end of it all, engineering organizations have become more efficient in the aggregate, to a point. And so while microservices and Kubernetes and all this stuff have enabled parallel work, it's made it easier to build even more complex software. Now you have organizations with hundreds of services named after Game of Thrones characters or things that you don't know, and you get paged at 3 a.m. for something you have no idea what it does. And so that volume and that complexity has made it very difficult to track ownership. You get paged for something. What does this thing do? Who owns it? Who do I talk to? Vulnerability comes up. Who's accountable for fixing it? It's very hard to capture that at scale. Cloud hosting, yes, it's made things easier and cheaper, but because of that, we tend to use more of it. We're more free with deploying things to the cloud. And so now you deploy something, you haven't touched it in a year, maybe it's not even used anymore, but now you're paying for all that compute, for all that storage, and obviously everyone today is thinking about cloud cost optimization. But with all the tools sprawl, the complexity, everything that we've now given developers to ideally make them better, we've now created more process and more noise, and the signal-to-noise ratio is horrible, right? Every developer has got 5 different teams asking them to do things. They have a production checklist they need to go through to get something to production. Security is top of mind for everybody, and none of these things are bad. These are all good things that we should be doing as engineering organizations, but developers have been bottlenecked. There's so many things we need to think about. So how do we cut through that noise, and how do we make things even more efficient? And so when we took a look at the landscape of what tools are out there today to help engineering organizations, we kind of put it in this graph of do tools help drive quality, or do they help drive velocity? At the end of the day, those are the kind of things we're thinking about as an engineering organization. And so we know one aspect of this is like monitoring, tooling, APM, DevOps platforms. And so those are really focused on performance, right? It's like, are things performing the way we expect them to? Are we breaching our SLOs? Are things in runtime, in the wild, doing the things we expect them to do? It could also be things around like CI/CD and stuff like that, where it's like, how do we move more quickly? You have things like engineering intelligence and metrics. So it's more like the output of teams. Like, are we shipping fast enough? Are we shipping often enough? How many incidents do we have? Are we getting bottlenecked in PR reviews? Stuff like that is interesting. It doesn't necessarily drive action, but it's tools that exist to help us kind of assess the situation of our organizations. And finally, you have more static information about what engineering teams are doing. That can be Git, that can be Jira, that can be Confluence, so code, things we're working on, how things work. It's more static, it's more like human-driven knowledge. And so each of these things kind of falls in different buckets, right? So when you think about CI/CD and things like that, they're really around quality, like are we doing things the right way? They're not so much driving velocity. To some degree they are, but for the most part, you think about them as quality gates. But when you think about development platforms or APM and things like that, it's around quality, but you're also trying, you're not driving as much velocity anymore. And so this is kind of the market today. It's kind of little bits and pieces of everything across the entire spectrum. But what's missing is like, how do we collect all this information and create a cohesive picture across all that stack, right? I have a service and all of its code in Git. There's things being worked on that's being tracked in Jira. That thing is deployed to 3 different clusters in prod and staging and dev. Is being monitored by Datadog, and maybe something else, and maybe something else, and maybe something else is being deployed by some pipeline, and maybe you have different pipelines, tools across your organization. You have some spreadsheets somewhere tracking some of this information. You have Confluence tracking docs. So how do you create a cohesive picture to say, this thing is deployed here, and this is its on-call rotation, and this is its monitors, and its SLOs, and then now we can create this picture to help us answer questions and drive more productivity that way. And so that's where internal developer portals are. Obviously, I wouldn't be giving this talk if it wasn't about developer portals. And so the idea behind developer portals are, there's a couple key requirements that a developer portal must have, right? The first thing is a system of record. That's kind of what we describe developer portals are. At the core is a system of record for all the information about things in your stack. So that's kind of that cohesive entity graph of everything in your engineering tooling stack. How do I create a single picture, a single source of truth for everything that's out there? The system of record, the cataloging, all that stuff should be part of your developer portal. The second thing is, how do I drive action? Okay, I'm collecting all this data. What now? Why did I collect all this data? It's because I'm trying to drive best practices, standards. We have things that we care about as an organization. How do I get people moving against that? How do I get the organization tracking towards that? And finally, now you're telling people, here's what we have, here's what's good, and here's how we're doing against that. And finally, how do we make it easy for people to do that? Can we help them self-serve the things that we're asking them to do? If we're asking them to follow best practices and standards around production checklists or security or whatever that is, can we now give them self-serve tooling to make that a one-click process or a couple-click, or whatever that may be? Can we give them self-serve tooling to make that easier? These are the 3 components that must be met in an IDP for it to be successful. And so, when we think about developer portals, I think one of the things that's happened in the market is you think a lot about, like, there's a platform team who's building an IDP, and they're kind of working in isolation, thinking about, like, our consumers are the developers. But we want to think about it from a product manager standpoint, right? So if you're a product manager on a platform team building an IDP, you would go talk to developers and do that research. That's exactly what we did. So we went out and we talked to a bunch of developers and engineers who are looking at developer portals. So not necessarily our customers, but just other developers who are thinking about IDPs. And we asked them about their pains, why they're looking at IDPs in the first place, and we had 3 key takeaways. The first thing, it's impossible to find information in an organization. It's unclear to developers what they should be focused on. Am I doing the stuff that's like feature development? Am I looking at productivity, reliability, security? What should I be working on? And finally, templatizing, scaffolding, self-serve of things like golden paths are probably the #1 thing that developers want. Make it easy for me to do the things that you're asking me to do. So the first thing, finding information. Most people say they can't find information. It's complexity. It's microservice sprawl, information sprawl. You have 10 different tools like we talked about. Developers just want to be able to go to one place and find information. What's out there? What does it do? Who owns it? Who can I talk to? Where is it deployed? Can I find all that information in a single place? And if I have that, then so many different processes can be built on top of that. And so one thing that we hear is finding information is a pain. The second thing, and we're seeing this kind of trending over time, is as information becomes more and more difficult to find, prioritization is becoming more important. Because now you have platform teams asking things of people, you have SRE teams asking things of people, security teams are like, okay, what do I do? Like, I've got so many things on my plate, what do I work on? And so giving developers clear prioritization around the things that they should be focused on, what they should be working on, can be and should be one of the things the developer portal solves for. We kind of secondary to that, we also hear that there's a lot of noise from many tools. You have your security tools yelling at you, Datadog or in Splunk and PagerDuty and all these other tools are yelling at you about something. You just have a lot of information, and again, going back to that signal to noise, there's a ton of things happening, so how do you assess all that information and make informed decisions about what you should be working on? And developers are telling us that noise from those tools is making it very difficult to figure out what should I be working on. And finally, templating, golden paths, self-serve. So an IDP should give people an easy way to get started with things, to scaffold things, to self-serve. It's like, hey, if you're asking me to do things, make it easy for me to do those things. So if I'm starting up something new, if I'm starting a new project, if I'm adding things to existing projects, can you make it easy for me to go and do those things? And so where does Cortex fit in? How does Developer Portal, how does Cortex help you with some of these initiatives? And so the way we think about this is we actually take those core concepts of an IDP and we expand and build upon that. And so the system of record is the core foundation of this all. And so the way we think about the system of record is how much of it can we automate? So can we pull information from your existing integrations, your tech stacks, and instead of you telling us a bunch of information, can we go out and help you discover a lot of this information and pull it into a single place? While giving you the flexibility and the extensibility to define your data models the way you see fit. So how you talk about your organization, how you talk about your taxonomy, giving you that flexibility while underlying that with all the different integrations so that we can find information for you and keep it up to date, which is one of the biggest problems in the system of record is I've got a bunch of data, it's gone out of date. With Cortex, a lot of that is automated. The second thing is on top of that, we've built our scorecarding product. So the ability to drive automated checks against the data and using that data to drive things like package upgrades, platform migrations, production checklists, security standards, service standards, all the things that you care about that maybe today you have a Confluence page tracking or a spreadsheet or something. How can we take all that and automate it and take it out of the hands of a few people and drive that action across the organization and then tell developers exactly what they should be focused on? And then finally, self-service. So can we give people tools to go and do those things themselves? And so the first thing is a system of record. I think one of the things that people struggle with is just collecting all the information to their IDP. We talked to a lot of people who have tried an IDP before, and they say, we're 6 months in, we still don't know what we have, there's tons of information out there, how do we collect all this stuff and make sense of it? And so one of our philosophies is look at your IDP as a pointer to your other tools. Can you create an entity graph by bringing in data from other tools to then create that cohesive experience? And so a lot of that is based on the integrations that we have. So we have over 50 integrations at this point, and a lot of it can be convention over configuration. So you tell us, like, hey, we're doing this standard tagging scheme. OK, well, boom, we've got this entire picture of your organization covered now because we can discover so much information about it. So how much can we pull from your existing tools so you're not keeping things manually updated? For example, ownership. Ownership of software is such a hard problem because people join teams, leave teams, there's reorgs. It's not very stable as a concept in engineering teams. And so one of the things we do as an example is we integrate with the other IDPs, like identity providers like Okta and Google Groups and all these things, but also HRIS tools like Workday, where we can sync all of your teams and team structures into Cortex so you can use that for ownership. So now if people leave or join the team, we're keeping that information up to date automatically so that you can have accurate ownership at any given time. Catalogs are automatically syncing, so we talked about ownership, documentation, dependencies, all of these things can be pulled in automatically from the variety of tools that you have. The really cool thing about Cortex is once you have all this data in the catalog, we have our own DSL called Cortex Query Language, which allows you to then go and query that data. So you can now ask it very complicated questions like, how many of my tier 1 services that are in production have been affected by the wrong version of a bad version of Log4j, have not been deployed in the last 24 hours, and doesn't have an owner associated with it. And boom, there's a list of services that are highest risk when something like Log4j hits the next time. You're able to query that data, correlate data across different integrations because you have a system of record that connects different data sources into a single place. The second thing in Cortex is prioritizing action. So there's a lot of different ways we do that. The first thing is the developer homepage. So for a developer, if I log in, I get an immediate picture of the things that matter to me the most. So my services and my infrastructure that I own, the health of those services, my pull requests, my reviews that are assigned to me, my Jira tickets, my scorecards and action items. So if I'm out of compliance with things, it'll tell me all the things that I should be focused on. So it's one place where I can go to get a lay of the land without having to go to 6 or 7 different tools. And we send alerts for these things too. So if you have a Jira ticket or a PR or a notification or something you're out of compliance with, we can go out and reach out to developers for you so you don't have to be going and prodding and poking at people with all this information in the catalog. The second thing is scorecarding. So if you have migrations, if you have audits, you have compliance standards, best practices, service maturity things, can you take those things and automate them away with all that information we're collecting from your tools and immediately tell you, hey, 50% of your services are meeting the basic level of maturity, 30% of your services are in that middle silver level of maturity, and so on and so forth. So how do we gamify, how do we push developers to be better across the organization, but also track things like migrations across the board? And what's really cool about the platform is it allows you to build exemptions. Because not every team is the same, not every service is the same. So being able to say, hey, this thing that doesn't apply to me, can we build that into the product to make it really relevant to every single organization? Reporting, obviously, I think this is one of the things that everyone asks for. If all this information in there, can you report on this in different ways? And so being able to break down things like reliability or service maturity across product areas, functionalities, teams, help you make more informed decisions. So instead of saying, oh my God, it looks like our monitoring sucks, you can say like, hey, how many of our services are actually meeting our monitoring standards? Are those teams doing well on our other metrics that we care about? If not, what are the things we should be pushing them to do more? Do we have teams that are maybe falling behind where we need to be prioritizing more tooling, more infrastructure, more resources? And so now you're doing more data-driven analysis of your organization versus just trying to look at your dashboards and say like, oh my God, like what do I do next? Self-service. This is kind of the next big theme of an IDP that we were talking about. And so one of the core components that we offer in Cortex is a scaffolder. So one of the things, obviously, in more mature service organizations, you end up building a lot of new services, right? Across the organization, people are spinning things up all the time. And so if you have these scorecards which are telling you, hey, here's all the things you should be doing, here's what good means, here's the golden path, how do we make that so easy? It says, hey, by the way, if you want to meet all those standards and you're creating a new service, here's a one-click way to do that that's going to get you 80% of the way there already. And so scaffolder is a great way of doing that. And the way we do this is by using an open source framework called Cookie Cutter, if you're familiar with that. It's a boilerplate generation tool. So you can give developers a way to come in and say, I want to create a new Spring Boot service, fill out a bunch of information, which you're fully customizing, and Cortex will create the repository, generate the code, add it to the service catalog, kind of really control the end-to-end process. And at the end of it all, developers have a new project that's meeting all of your standards from day one. Actions. So how do you help people orchestrate and do things from within the portal? Because if your portal is just a bunch of information, no one's going back in there. You need to put things in the portal where people are taking action, they're doing things in the portal to drive that feedback loop of adoption. And so actions are a way to drive these kind of triggers to external tools, to internal tools, to trigger some sort of workflow outside of the system. So basically HTTP payloads with like no code, low code UIs. So for example, what we use this for internally as we dog food Cortex is to deploy our backend to our Google Cloud. And so we have a button where developers can go in, they open the service catalog, they click on the service, they hit the deploy button, and behind the scenes, it's going off, it's triggering the GitHub action workflow, it's orchestrating that, sending information back to Cortex. And so now developers have a one-click way to deploy tools. Instead of telling every new developer that joins, hey, this is the pipeline you got to go and run, here's the right parameters you should fill in. It's like, go to Cortex, click the deploy button, and you're good to go. So now you're building that self-serve into the platform itself. And then the last thing I'll talk on is plugins. So with Cortex, you can actually build on top of our platform with the plugin system. So you can build your own React, TypeScript components, UIs, embed them inside of the portal, embed them throughout the service catalog. So if you want to build your own custom deploy tooling, if you want to build your own Kubernetes control plane and expose that, you can do that inside of the portal. So you're not restricted to those integrations we were talking about earlier. You can build on top of our platform and really extend its capabilities with anything you want. So the way we think about this platform is let us give you the plumbing. Don't do the boring stuff. Don't build an AWS integration. Don't go and build an integration with Datadog or PagerDuty. Let us do those things so that you can spend time building plugins that are very custom to your workflows and the things that matter to you the most. And last but not least, this is kind of how we think about the IDP space as a whole. So when you think about what people are trying to do with Cortex or IDPs, we talked about at the start, it is continuous improvement. How do we get people to keep getting better over time? And so the way we've seen customers and people really roll out IDP successfully is by breaking it down into this framework. You can't just jump straight to self-serve. That's going to be setting yourself up for failure because you're not knowing what am I optimizing for? Why am I improving this particular experience? And so the way you do that is you start by aggregating information. What information do we have? What's out there? How do I collect this information? Then let's say, okay, now with this information, where are we today? What are the standards we care about? What is the baseline that we are at today so that we can measure where we're going next? Then, using initiatives, you drive action. Tell developers clear things they should be focused on to improve reliability or maturity or the things you care about. Once you start doing that, you'll see opportunities for enablement and optimization. Say, hey, we're asking people to do these 3 things. that's really hard. Let's go build some self-serve experiences to make that easier. So now you're creating a feedback loop where you're aggregating information, you're assessing it, you're telling people action, you're optimizing it, and you keep doing that. And all of a sudden, you created a flywheel with your IDP. And so with that, that is IDPs, adoption, and everything that we think about, a little bit about Cortex. Thank you all so much.